Then we're going to talk about factoring. All right. So let's talk a little bit about distribution. If I have a number times another number, let's say the other number is the quantity B plus C. And remember, when we have parentheses, we say quantity, right? And quantity simply just means a number, okay? So this would be A times a number. But a way that we can find out what the number is through distribution. So we can distribute the number on the outside of the parentheses over addition. So this would be A times B plus, A times C. A times B plus A times C. Now we can do the opposite as well. We can pull out a common factor. So these two terms have within them common factors, the factors of A and B and the factor of A and C. So we can pull out the common one, which is the A, and what's left is B plus C. All right. All right, and that's what we call factoring, okay? The word factoring simply just means that you are taking a number and you are pulling out factors, okay? And we do this a lot with numbers themselves. So in this case right here, we have 24. We can factor that. We can create what's called a factor tree. So I'm going to factor this number 24 all the way down to the prime factors, okay? So all I need to do first is figure out, okay, what two things can I multiply together to give me 24? And they could be anything. You can use 4, 6, 2, 12, any of the factors you can start with. So let's just say 2 and 12 is what we start with. Okay. Now, 2 is a prime number. 12 is not. 12 has factors within it. We can factor that down to, let's say, 3 and 4. You could also do 2 and 6, either way. And I'm going to bring that 2 down. Now, what I have is, if we go here, 2 times 12 is 24. And down here, 2 times 3 times 4 is 24, because I factored this 12 into two components. So the 2 and the 3 are prime, but the 4 is still a composite number, and it's composed of two 2's. So if I look at my primes here, I have 1, 2, 3 2's and a 3. So in my calculator, if I were to do 2 times 3 times 2 times 2, that would give me 24. And so the way that we would write that is we have 2 to the third power times 3. That equals 24. These are the prime factors of the number 24. Okay? All right. All right. So we're going to look at a constant monomial. That constant monomial we're going to say is 81, and we're going to factor it. All right, can I factor this down at all? Let's see. That's 9 times 9, and then 9's are 3 times 3. So this is 3 or 4 3's multiplied by each other to get 81. 3 to the 4th power. That's the prime factors of 81. Give you a second to write that down. Okay. Now let's look at a quadratic binomial. A quadratic binomial. So we're going to do 8x squared plus 4x. All right, so let's factor this. So in order to factor, I've got to figure out what things are common, right, between the two here. And we call those the common factor. Between the two terms, what do each of these have in common? So let's take the 8x squared first. And let's look at its factor. So that's 8 times x squared. X squared is just x times x. 8 is 4 times 2. And 4 is 2 times 2. So this is 2 cubed times x times x. Okay. Now let's take our 4x. Let's go ahead and factor that down. So that's a 4 times an x. And 4 is 2, 2. Whoops, that's an x. All right. So what do these two factors have in common? All the prime factors of 4x and all the prime factors of 8x squared, do they have anything in common? Well, they've actually got two 2's in common. We see that. And they have one x in common. So I know that I'm going to be, what they have in common is a 4x. Okay. Then I'm going to have a 2x left over here. Left over here, I'm not going to have anything. So that's just going to be a 1. So when we look here, we can see that we can pull out an x out of each one. So let's do that first. That's kind of obvious. If I pull an x out, then in my parentheses, this is sort of reverse distribution, I'm left with 8 times x plus 4. And I know that because if I were to distribute this x back in, this would be 8x squared plus 4x. Now, I'm going to pull a 4 out of each one of these. If I pull a 4 out of the 8x, it's going to leave me with 2x. And if I pull a 4 out of here, it's going to be left with 1. Now, a lot of times I'll get students that'll leave a 0 here. And this is why that can't happen. Because if I do 4x times 2x, that gives me 8x squared. If I do 4x times 0, that would give me 0. I need 4x. So that's why that cannot be 0. That must be a 1. So that when I distribute the 4x here, 4x times 1 is 4x. So my final answer here is 4x times the quantity 2x plus 1. And that quadratic binomial has been factored by pulling out the common factor. All right. Now let's look at a cubic trinomial. Let's look at a cubic trinomial. We're going to do 12y cubed minus 4y squared plus 3y. All right. Let's look at each one of these terms. Terms are things we add. Well, notice we've got a subtraction sign there. So a lot of times what I will do to make this a little easier to look at is by the definition of subtraction, change that to a plus sign. And that makes it a little bit more clear. All right. Got a 12y cubed, a negative 4y squared, and a 3y. All right. Now we're going to look at their common factors. Now, just by looking at it, I know I could pull a 3 out of here and a 3 out of here and a 4 out of here and a 4 out of here. But what do I have common between all three terms? Right? I can't pull a 4 out of the 3. I can't pull a 3 out of the -4. So what can I do? Well, if we factored this, this would be 4 times 3, 2, 2, 3, and of course, 3y's. If we factored this, we'd have a -4 and a y squared, -2 and a +2, and a y and a y. And if we factored this, that would just be a 3 and a y. Well, if we look between these two, we could split that -2 into a -1 and a 2. So we've got two 2's on each here, two y's here, but we don't have any 2's here and we only have one y. So in reality, all we have here is one y in each of the three terms. That's all we have in common with the three terms. So that's all we can pull out, is we can pull out the y out of each one of those terms. So I would have a y on the outside, and then I would multiply that by 12y, and this would change to squared because I'm pulling one y out of there, minus 4y because I'm pulling one y out of there, and then plus 3 because I'm pulling the y out of there. And notice where my parentheses are. The parentheses are very important here because that tells you that I'm taking this y and I'm multiplying it. I'm distributing that into the whole quantity. Remember, if it's surrounded by parentheses, we call this a quantity. All right, and what's left inside here, if we just look about what's inside, 12y squared minus 4y plus 3, that, just what's inside there, is a quadratic trinomial. So we started with a cubic trinomial, we factored out a variable, and inside here we were left with a quadratic trinomial. All right. Now we're going to look at a quartic 7-degree polynomial. A quartic 7-degree polynomial. All right. So I'm going to start with a 12 x to the 7th minus 6x to the 3rd plus, let's do 4x minus 2. All right. So here we have 4 terms, and I'm going to change my negatives to positives. So we're going to have 12x to the 7th power plus a negative 6x cubed plus 4x plus a negative 2. All right. So here are my 4 terms. 1, 2, 3, and 4. Degree 7. This is a quartic 7-degree polynomial. And now I want to see what they have in common. All right, you'll notice that I only have x's on the first 3 terms, not on the last one. So I can't pull an x out of each term. You'll notice that I've got a 12, a negative 6, a 4, and a negative 2. So I could pull a positive 2 out of each one of these, because this ends up being a, and I'm not going to do the x's since we know we don't have any x's here, but this would be a 4, 3, 2, 2, 3. This would be -1, 6, 3, 2, -1. This will be 2, 2, and this is -1, 2. So if we look here, we see that we have a 2 in common at each one. Now, you may be able to kind of look at that and already know, oh yeah, that there's a 2 in common there. If everything is even, you know you at least can pull out a 2. All right, so let's go ahead and pull out a 2 out of the 12. I'm going to be left with 6x to the 7th plus, I'm going to pull out a 2, so I'm going to be left with -3x cubed plus, if I pull a 2 out of the 4, I'm left with 2x, and then plus, if I pull a 2 out, I'm left with -1. All right, now I'm going to turn it back to subtraction to make it a little bit easier to look at. So 2 times 6x to the 7th minus 3x to the 3rd plus 2x minus 1. And what's interesting is here I started with a quartic 7-degree polynomial, and inside the parentheses, I still have a quartic 7-degree polynomial. All right. Let's do we're going to do an 8th degree binomial. We're going to do 7x to the 8th minus 49. All right. So here we've got two terms, 7x to the 8th plus, and then a -49. Those are my two terms. Two terms, so it's a binomial. The largest is an 8th exponent, so it's 8th degree. So what can I pull out of here that's common? This has eight x's, but this has no x's. So there's no x that can be pulled out of both, all right? So what are the common factors here? Well, if we look at just the number, this is 7, obviously x to the 8th, but we won't break that down because we don't have any x's over here. But if I look at the -49, -1 and 49, and then I break down the 49, that's 2 7s. So I know I've got two positive 7s that are the same. So I can pull that out. I can pull a positive 7 out of each one. So if I pull a positive 7 out of the first one, okay, I'm left with x to the 8th. And then here, if I pull a positive 7 out, I'm left with a -7. Right? So 7 times x to the 8th is 7x to the 8th. And 7 times -7 is -49. So it works. I'm going to go ahead and change this back to subtraction to make it a little bit easier to look at. X to the 8th minus 7. And that is that 8th degree polynomial. All right. Now let's look at quintic let's go with a trinomial. Quintic trinomial. We're going to have 13x to the 5th plus 26x to the 3rd minus 39x squared. All right. Quintic trinomial. So first thing I'm going to do is change my subtraction to addition. You don't have to do that. It does make things a little bit more clear. All right, that way everything's addition. We can move things around if we need or want to. Here we have 3 terms. That's my trinomial. Largest exponent is 5. That gives me the quintic. The coefficients, if you remember that, the numbers that are multiplied by the variables are 13, 26, and negative 39. All right, so this one looks like they all have x's, so let's go ahead and do our due diligence. So 13 is a prime number, so it stays at 13. X to the 5th, obviously, is 1, 2, 3, 4, and 5 x's. 26 is 13 and 2, and then x to the 3rd. And so x, 2, and 13. Negative 39 is negative 1 and 39, and x squared. Negative 1, 39 is 13 times 3. X squared is x times x. All right, so I see a 13 in each one of these, and I see 2 x's in each one of these. So I'm left with 3 x's, x to the 3rd, a 2x, and a negative 3. All right, let's see. So here, if I pull out what I have in common, which is 13x squared, 2 x's in each, and 13 in each. So if I pull that outside, 13x squared, then I'm left with x cubed. X squared times x cubed gives me x to the 5th. Then if I pull a 13x squared out of 26x cubed, you could see it here. I'm just left with 2x. So 13 times 2 is 26. X squared times x is x cubed. And then here, plus, if I pull a 13 out of negative 39, I'm left with negative 3. 13 times negative 3 is negative 39. And if I pull an x squared off the x squared, then x squared times negative 3 then my x squared will reappear there. 13 x squared times negative 3 is negative 39x squared. So now I'll change my definition of subtraction back to just subtraction. So 13x squared times x cubed plus 2x minus 3. All right, so we went from a quintic trinomial. Now if we look inside, we are a cubic trinomial. Still a trinomial, but we lost 2 off of our top degree, so we went down. But that is the final answer. All right. Okay, let's do 100 x to the 4th plus 60x squared minus 100x minus 50. All right. So let's go ahead and name this polygon. Well, if we're going to name it, we'll recognize that there are 1, 2, 3, 4 terms. Okay. And 4 terms doesn't have a special name. That's just a 4-term polynomial. Or no, yeah, does it? No, yeah, just a 4-term polynomial. Okay, a degree 4. And degree 4 would be a quartic. Quartic, quartic, 4-term polynomial. All right. we notice that they don't all have x's. This last one is just a constant. So we're not going to be factoring out an x. Anything else here? Probably have some numbers we can factor out. So I'm going to go over here and just make a factor tree out of each one of these. So here's my 100. I know that's 10 times 10, and each 10 is 2 times 5. And here my 60. I know that's going to be 6 times 10. The 6 is going to be 2 times 3, and the 10 is going to be 2 times 5. So I've got the 100. I've got another 100 here. It's just the only thing I need to add to that is a -1. And then the 50, that's going to be 5 times 10. And this is 2 times 5. All right. So let's see what we got in common. Since I've got two 100s, I'm just going to do one since they'll have the same exact factors. Well, I see that they each have a 2. Some of them have more than one 2s, but this 50 only has one 2. Um, then, let's see. They also each have a 5. All right, so what do they have in common? The common factor is 10. And what you'll notice is this is the greatest common factor. Okay. 2 is a common factor in each one. 5 is a common factor in each one. But when you take all the common factors and multiply them together, that is the greatest common factor. And that's eventually what it is that is being pulled out of the polynomial. All right, if we pull out the 2 times 5, I'm only left with 2 times 5, which is 10. If I pull out the 2 times 5, I'm left with 2 times 3, which is 6. And here, if I pull out the 2 times 5, I'm just left with a 5. So I'll be left with a 10 here, a 6 here, a 10 here, and a 5 here. And that makes sense, because if I pull out a 10, then I would have a 10x to the 4th. If I pull out a 10, I'd be left with positive 6x squared. If I pull out a 10, I'd be left with negative 10x. If I pull out a 10, I'd be left with negative 5. And it remains a quartic 4-term polynomial. Let me check on one thing real quick. Make sure I've covered everything that's going to be on all of your homework. So give me just a second here. I'm going to look at the last two homework assignments for chapter, or we're in section, or week 5. Are we in 5? Okay. Hmm. I think I need to resend homework 5.5 and 5.4. Let me see here. So I sent the wrong factoring. Oh, it looks like I sent one with answers. Yeah. Okay. I'll have to resend out homework 5.4 and 5.5. So sorry about that conclusion. Or sorry about that confusion. Because I've got some factoring in there that I don't think I'm gonna cover until later. And that's two binomials, because we'll do the graphing lines next week. And the week after, along with exponents, then rational expression, scientific notation, word problems, and then we get back into factoring. Okay. Yep. So why don't we let me change this. All right. So let's go ahead and we're going to revisit distribution again. So if you remember, distribution was you have a number multiplied by a quantity. If I factor that in, I get AB plus AC. And what we just did in the last several examples is we found the common factor and we factored that out, which is kind of reverse distribution. So what I'm going to do now is give us some distribution to do. So we're going to have 4 times the quantity, 6x squared minus 7x plus 2, end quantity plus 7 times the quantity x minus 5. So we're going to do distribution, and then we're going to combine like terms. All right, so we're going to have some fun here. Let's go ahead and distribute this. So 4 times 6 is 24, and then my x squared. And then I have 4 times negative 7, that's negative 28x. And then 4 times 2, that's going to be plus 8. All right, then here I have positive 7 times x, that's plus 7x. And then I have positive 7 times negative 5, that's minus 35. All right, now I'm going to look for like terms, right? What are like terms? Like terms are things with the same variable, same exponent. Same variable, same exponent. So here we have, and I'll go ahead and change all of my subtraction to addition. It's not a bad habit to get into. It's not necessary right now, but it does come in very useful later. All right, now let's look at like terms. So I don't have any other x squared, so I know my 24x squared is going to remain the same. Now let's look at x's. I've got a negative 28 and a positive 7. So I can combine those into a negative 21x. And then I've got a positive 8 and a negative 35. So that would be a negative 27. All right. Now I can change this back. Oops, that's plus a negative. Right. Now change it back to subtraction. 24x squared minus 21x minus 27. Now, is there anything else? Now that I've combined everything, can I actually pull anything out of this? Now that I've taken my original expression here, I've multiplied it all out, I've combined all my like terms, can I now factor it? Can I now pull anything out? What I don't want to do is factor out and get back to this because we haven't done anything. But here I might be able to pull something out. So if we look at 24, and if you know what it is, you can go ahead and do it on your own. But if we pull out of 24, that's 12 and 2, 6 and 2, and 6 is 2 and 3. 21 is 7 and 3. 27 is, let me think about this, 3 and 9. And 9 is 3 and 3. So we can see how we actually have a 3 in each one of these, right? Out of my 24, if I pull the 3 out, I'm left with 2 times 2 times 2, which is 8, right? So let's look at each one of these. I pull a 3 out of here, pull a 3 out of the 24. That I'm left with 8. And then obviously my x squared. I don't have x on this last term, so I'm not going to be pulling out any variables. Negative 21, I pull out a positive 3. I'm left with negative 7x. And then minus 27, if I pull out a positive 3, I'm left with negative 9. All right. It's a lot of factoring and distributing. It's kind of what we're practicing right now. Factoring and distributing. All right, so now let's look at another one. Let's do 12x squared times the quantity 4x squared plus 3x squared plus 2x. Then we're going to have minus 4 times 6x cubed minus 4x squared. All right. We are going to multiply all that out, combine like terms, and then factor it. Let's get to it. All right, 12x squared times 4x squared. Well, 12 times 4 gives me 48. And then the x squared times the x squared gives me x to the 4th. All right, 12x squared times 3x squared. So 12x squared, and we actually could have initially, since I have an x squared here and an x squared here, we could have combined this before. Multiplying through isn't going to change anything. We could have combined this before. So 12x squared times 3x squared, that's plus 36x to the 4th. 12x squared times 2x, that's plus 24x to the 3rd power. All right, now what I'm going to do is I'm going to say plus, and then I'm going to do negative 4 times 6x cubed minus 4x squared. And I did that kind of on purpose because it's important here. This is one of the mistakes that I see students make a lot. So let me get this copied here on the next line. All right, so this is what I see happen is they see this 4 and they go through and this becomes minus 24x minus 16x squared. And I'm sorry, minus 24x cubed. They fail to actually bring in a whole negative itself. So negative 4 times positive 6x cubed is negative 24x cubed. And then negative 4 times negative 4 is positive 16x squared. All right, so now it's time to combine some like terms. These first two that we already talked about are like terms, the 24x cubed and the negative 24x cubed are like terms. In fact, those are opposite of each other. So we know that they're going to cancel each other out. All right, and 48 plus 36, I've actually got, let me work that out here. 84. So this is 84x to the 4th, and then plus 16x squared. All right. So I've got a binomial here. It's a quartic binomial. And let's see what we have in common. So I'm going to take my 84 and I'm going to do a factor tree. Okay, that's 2 and 42. And 42 I can divide by 2, and that's 21. And then 21 I can divide by 7, and that's 3. All right, I take my 16. My 16 is 4 times 4, and my 4s are 2 times 2. All right, so I've got 2 2s and 2 2s, and I'm left with 21 and 4. All right, I've also got 4 x's here and 2 x's here, so I can pull out 2 x's out of these two terms. So I'll pull out 2 x's, or an x squared, and I'll pull out my 2 2's, which is a 4. 2 times 2, 2 times 2. If I pull a 4 out of 84, I'm left with 21. And if I pull a 4 out of 16, I'm left with 4. If I pull x squared out of x to the 4th, I'm left with x squared. And if I pull x squared from x squared, we're just left with the constant there. And that is the answer. 4x squared times the quantity 21x squared plus 4. All right. Let's do another one of those. Let's do do 60 y to the third minus 360 times y, that quantity, minus 2 times negative 540 y squared minus 120 y. Yeah, we'll just leave it like that. All right, we'll have this be a negative 2y there. Okay. So let's have some fun. Let's get this thing factored out, or let's get this thing distributed out, and then we'll factor back. Okay? All right, so here I've got a quantity, but what's out in front? When there's nothing out in front, that's not a 0, that's a 1. And if I multiply each of these by 1, it simply returns itself. So that just leaves me with 60y cubed minus 360y. Here, I've got a negative 2y, and I'm going to multiply that by a negative 540y squared. So the first thing I'm going to notice is these two negatives are going to leave me with a positive. Now, we could go ahead and change this to plus a negative if we wanted to. It's not going to change anything, but here I think we can kind of figure out what's going on. And then 2 times 540. So that's going to be 1080 y to the third power, because I have y times y squared. All right, now I have negative 2 times negative 120y. The negative times the negative is going to be a positive. 2 times 120 is going to be 240. And y times y is just going to be y squared. All right. So initially, I can see I have y in each one of my terms. And if you want to change this negative to a positive, you can. I know I'm pulling out 1y because that's right here. I can't pull any more out than 1 out of this one. And so what they each have in common is at least 1y. This has 3, this has 3, this has 2, but that middle one is a y. So that's what we can pull out. All right, so let's go ahead and factor these. I know I can at least pull a 10 out, but we'll go ahead and factor each one. So 60, that will be 6 and 10, 2, 3, and the 10 is 2, 5. 360, that'll be 10 and 36. 10 is 2 and 5. 36 is 6 and 6. And each 6 is 2 and 3. All right, 240. That's 10 and 24. 10 is obviously 2 and 5. 24 is 2 and 12. 12 is 3 and 4. 4 is 2 and 2. So it's a 2, a 5, a 2, a 3, a 2, and a 2. All right, then if I factor my 1080, that is 10 and 108. 10 would be a 2 and 5. If I take a 2 out of 108, that gives me 54. If I take 2 out of 54, I think that gives me 27. So we got a 2, 5, 2, 2, and a 27. The 27 is 3 and 9. And the 9 is 3 and 3. All right. So getting kind of the bottom of the page there. Let me kind of be clear. All right. So for the 1080, I have 2 times, I've got 1, 2, 3 2s. And then I've got 3 3s. And then I've got 1 5. All right. So let's see what we've got in common. Well, let's see. I've got a 5, 5, 5, 5. So they each have a 5. Looks like they each have at least, do they all have 2 2s? 2 2 there, 2 2. Yep. So I've got 2 2s. Does each of them have a 3? There's a 3, there's a 3, 3 to 3. Good. 3, 3, 3, and 3. And we pulled the entire 60 out. So that's how we know we're pulling 60 out. So what do they have in common? 2 times 2 times 3 times 5. That's 4 times 3 times 5. 12 times 5, 60. They have 60 in common. So we're going to pull a 60 and a y out. Okay. So the first one's easy. If I pull a 60 out, I'm just left with the y cubed. And I pull a y out, I'm left with a y squared. All right, and I can actually calculate here what's left out of the 1080. That's 3 times 3, that's 9 times 2, that's 18. Here, it's a 2 times 2, so for the 240, I'm left with a 4. For this 360, it's 2 and 3. I'm left with 6. All right. Next, I have minus 360y. If I pull the y out, then I'm just going to be left with a number. And then if I pull a 60 out of 360, I'm going to be left with 6. So minus 6. All right. Plus 1080. If I pull a y out of the y cubed, I'm going to be left with y squared. And we calculated that I would be left with 18. If I pull the 2 2s, the 3, and the 5 out, I've got a 2, a 3, and a 3. Multiply that together. 2 times 3 is 6, times 3 is 18. Then finally, plus 240. If I pull a 60 out of 240, I'm left with 4. Pull a y out of y squared, I'm left with y. All right. Now, we just have to rearrange this. Let me rewrite it and rearrange it. So 60y times the quantity, y squared minus 6 plus 18y squared plus 4y. All right. Well, we'll notice that we actually have some like terms, 18y squared and y squared. So I can combine those two. And that gives me 19. So 60y times 19y squared minus 6 plus 4y. Now, what I'm going to do is I'm going to change this negative 6 to positive. through the definition of subtraction, positive or plus a negative 6. And the reason is because I'm going to have the 4y and the negative 6 switch places. Because it is convention to always write terms, okay, in descending orders of your variable. Okay, so y squared, then y. Notice we have a y out here, but that's a factor. Those are multiplied in. So when you have terms like we do here, it's descending powers of x, or descending powers of your variable. So power of 2, power of 1, power of 0. All right, that is it for today.